Good afternoon. It's a Saturday. It's a gorgeous day. Well, sort of. I've got windows open. Seems like a great time to do some programming on a Tandy 1000. Well, this is going to be an emulated Tandy 1000 because sadly I personally do not currently own a Tandy 1000. I know, for shame. But I have already gone ahead and installed, or I within the emulation environment installed Turbo-C++ by Borland for DOS, and that's what we're going to be programming in. So let's go ahead and switch over to our nice and blank development drive that I've set up, and let's go ahead and make a folder to work in. All right, project, open project. We're going to go ahead and do that. Okay. Now, pardon me. Now, Borland Turbo C++ for DOS is a little bit funny. It's a very old school type of environment. So it doesn't actually save projects until you actually close them. So because we are almost guaranteed at some point to cause a lockup of the system requiring an effective system restart, we're going to want to close the project every time we add a new file to it so that it saves the fact that we've added a new file to it. So let's go ahead and close the project so that it knows that we've made something. And then we'll go ahead and reopen it. Oh, it didn't save it. Oh. That's okay. I think we might have to actually like create a source file. So we'll make our main source file. You know, it doesn't have to be super complex. We'll just do a pound include stdio for standard input output. Get our int main with our parameter being the standard parameter for or parameter list for getting DOS command line parameters. And we will return 0 because this is a function expecting an integer return. So let's go ahead and save as, and we're just going to call this main.c, and then project. Oh, I've got it. Oh, that's the wrong key. Ah! Oh, God! Okay, well, you know. Okay, window. Next is F6. Okay. So let's add an item. Yeah, we want to add the C file. Thank you. Okay, close project. Close project. All right. So if I go back, there we go. All right. So, oh, and of course it's got fint. What's a fint? Ay, ay, ay. It's a floating point integer. Yeah, that makes sense. Okay. So, we've got this set up. The next step is going to be establishing our main. In fact, actually, before we do that, let's go ahead and save, and we'll go ahead and say make exe. All right. I know, riveting stuff. This, right? Yeah. It's complaining because we're not using all of our parameters. Let's go ahead and say run. And okay. You know what? I should probably actually put in a printf here so that we can just verify that yes, our program compiles. So we'll go ahead and send an fprint with hello world and a new line character. Then we will make... Wow, 220. I've got a lot of code for just those 6 lines. 228 lines of code compiled for just 6 statements. I know, it's because of the standard lib that I've included. But I've indirectly included by having that. Alright, so it ran. So I can go to the window menu and click output. And there we are. So let's go ahead and close that window. Okay. So because we are making a DOS game intended for a... I mean, I'm going to be starting this off targeting the Tandy 1000, but we are eventually going to want to support other systems. So at some point, I'm going to add a menu using all printfs and what have you. But, so actually, let's go ahead and add a little comment block here. And we'll say add traditional DOS prompt hardware menu here. Just okay. We'll title this to do. Okay. So just in case, save. All right. So the first thing we're going to want to do with our game, or our game engine, I suppose, is what I'm actually making, is we're going to want to establish some functions for setting and resetting the video subsystem. We're going to go ahead and put that in a separate file because that is also going to contain some drawing functions later on. So let's go ahead and create a new file. We're going to save as. We're going to call this Video.c. Alright, and let's go ahead and include it into our project. Add item. Video.c. There we go. So, once again, because we've made a change to the project, we close the project, save all files, then project open. For the most part, we're not going to have to do this too often, so I know it's slightly aggravating at the moment, but it's going to become like a null issue later on. So it's just a big thing while you're setting up your project that you want to do that. That or what I traditionally do is I do all of my code editing in a modern interface like Notepad++ or something, and then I come into Borland Turbo C++ just to manage the project. And usually by that point I've got multiple source files already established, so I can just go through and add them all at once, save the executable, and get on with my life. So, but we're not doing that in this. We are going to go ahead and start off our video library file with just a quick bit of header information. So we're going to say created, and it is... God damn it. Oh, it always throws me off that it doesn't like the number pad. I've gotten so like just dependent on that. I wish I could get DOSBox to just default start with the number pad active. Anyways, so it's August 13th? Yeah. Oh, insert is still active. Okay, so we're gonna the engine that I'm working on is actually Gorgon 2.0. So just a quick little bit of information. and we will come back to that at some point. We're also going to need to make a header file, which does not need to be included into the project, but we are going to save this as video.h. So save as video.h, because this is our header file, which also means we're going to want to start it with a if not defined statement. I'm going to say video h. If it's not defined, then we immediately define it, and then end our define sequence. This is so that in case there ends up being some recursive inclusion in a file later on, it won't try to double up the code that's in this file, because old compilers will try to allow you to compile a single file multiple times into the same object file, and that usually causes naming collisions because, you know, obviously you've already defined these things. You're not supposed to define things multiple times, so it just becomes kind of a headache. Modern systems, I think, a lot of them are, especially like modern languages like C# and Java, are programmed around kind of like compartmentalizing so much that you don't have to worry about this kind of overhead, but it's a thing. Alright, so what we're going to want to do is we're going to want to create a an init function and a quit function, right? So let's go ahead and save that, and then F6 back to here, and we're going to actually define that. Ooh, actually, let me say int mode, and let's go ahead and define some modes. So right now, actually, let me call that video mode Tandy, and I'm going to have to double check this real quick. Hold on. See, if I were truly prepared, I would have all this information already pulled up, but I'm not, because I am a scrub. So, list of video modes, we'll say int 10h, because that's what we're going to be using. Oh, where are we going? No, I don't want the Wikipedia page about that. I want the actual list. Okay. So, let's see. Where's the table? Here we go. Alright, let's see. What we want is we are going to want this to be, I suppose, really we should have started off by saying what the goals were of this project. So let's go ahead up here on main, and let's go ahead and say what our goals for this engine are, because that's generally pretty helpful, right? So we'll say Gorgon 2.0, because Gorgon 1.0 is what this is looking to extend. Gorgon 1.0 was kind of slapped together for a game jam, kind of like what this is almost being done for, sort of. But Gorgon 1.0 was me learning a lot of things, and the code tended to be a little bit messy because I didn't really understand concepts going into it, and so spaghetti code ensued. Sorry. So what we're going to want to do is we are going to be defining our video, which is always going to be... God damn it, it did it again. Okay. Can I... Thank you. Okay. What did I just do? Okay, there we are. Okay, so our target resolution is going to be 320 by 200. which is the standard set by, I think it was CGA originally, for their graphics mode. Only we're going to be doing it with 16 colors. Planned hardware support. And we are going to be supporting, obviously, the Tandy 1000, because it is awesome. We are also going to eventually write an EGA driver, and if I can pull it off, I would like to also support the Plantronics Color Plus. If I can find good information for it, I might also try to support the, I think it's Barebones CGA that supports 16 color composite out, but I've never worked with that because I've never had a computer use composite out to connect to a display. It's always been through either an EGA or VGA connection or connector. So I actually don't have a lot of experience with that. Sound, we are going to support, oh, too many lines. Obviously, PC speaker, because what classic DOS game did not support at least some fashion of PC speaker? We're also going to obviously support the Tandy 3 voice sound system. And if I get around to it, we'll go ahead and support AdLib. Now, let's go ahead and say memory goals. We want this to fit on a single 1.44 megabyte floppy. I should probably go ahead and say floppy there. Okay, there we are. So we want it to fit on a single 1.44 floppy. We want our EXE to be less than 128 KB. And let's see, what other targets do we have? We want to fit all code and content within 640K. So we are doing this in 16-bit mode. 16-bit DOS generally has a hard limit of 640K. There is support for EMS and XMS memory, which can take you into the megabytes, but we're going to kind of avoid that for this project. If it can't fit in 640K, we don't want to do it. That's it. That's all there is to it. we are going to make this oh god, what's his name? Oh, it's fallen out of my head. Oh, why? I cannot think of his name. We are going to make this Bill Gates approved by keeping it under 640K of memory. We are also going to go ahead and include our Video.h. And then what we are going to do is we're going to type V in it, and we're going to use video mode Tandy for right now. Eventually we'll add in some menus when we've got other video modes supported. Video quit. Now, if you remember, video V init is supposed to return an integer. And the idea behind that is to say whether or not we were successful in setting the video mode desired. So what we're actually going to do is wrap this in a if statement. And now old school C has a fun, or at least on DOS, has a fun like quirk in that if you say if and then a value, just a variable or a return value, what you're really doing is you're saying if it does not equal 0. So we're going to say if not vinit, because then that will do a logical inversion of that if the return value is 0. So this basically is a kind of DOS programming shorthand for if vinit equals 0. And then we will go ahead and do that. And we'll go ahead and put in a getch. No. Yeah, there we are. Getch. And that's in con.io. Well, since we are no longer using, well, I mean, we will end up using that, so I'll leave that there. So, con.io.h. It's going to bother me that these aren't in alphabetical order, so give me 1 second. So the whole reason why we're using getch, which I need to check to see if it actually has... Okay, that doesn't take a parameter. Good. Okay, so we're using getch to pause our program and wait for the user to interact with it. So we'll say save, and then we will swap back over into here, and we'll say int mode. And then we'll come down here and we'll say void v... Tab sneaking its way in. It's just, I'm borrowing my wife's keyboard, and she's got one of those fancy keyboards where the keycaps are designed to look like an old typewriter, and it messes me up. The keys are the wrong shape. I don't care if they're a standard alignment. They're the wrong shape, and it messes me up, and I have a hard time typing on this. I'm sure you're asking yourself, surely you have a better keyboard. And technically, yes, I do. But all of them are PS2, and my computer that I'm working on right now does not have a PS2 connector, only USB. And hers was the only spare USB keyboard that we had. I really need to go out and buy a new USB keyboard for this workstation. I do have a fancy USB keyboard upstairs in my bedroom, but I really don't want to be moving keyboards backwards and forwards if I can help it. So, anyways, so now we have some choices here. We can do this by calling a library function, but I kind of want to eventually work my way to not needing any of the standard C libraries at all, because they can tend to be a little bit on the large side code-wise. In fact, if we go to our user screen and... Oh, man. Do I actually have to... I actually have to quit out. Okay. Well, let's save all. And let's quit out real quick. And let's just dir our folder. So, I haven't even gotten my video functions added yet. This is just it saying hello world. In fact, I believe that is, yep, just a hello world exe in DOS is 11.7K. That's a lot, and all of that is basically just the C standard libraries. So our goal is to work away from those. And there we go. And Borland likes to get us back to where we were. So what we're going to do is we're actually going to write some inline assembly. And we are going to move AL. I'm going to want that to be a char. So when doing inline assembly, the system does not like Borland, I think it's Borland C++ will convert it into an assembly file, which will then get passed to Turbo Assembler. It does not like trying to fit a 16-bit value into an 8-bit register. It doesn't know how to deal with it, and unlike a lot of like 6502 assemblers that I've messed with, which have like, ways of choosing whether to use the high byte or the low byte. If Turbo Assembler has that, I've never seen it, so I'm not familiar with it. So we are going to move our mode value into AL. We are then going to set AH to 0, and we're going to call int 10H. Pardon me. Actually, we're going to be calling this from a couple of different places in the program. So we're actually going to make a function, which is going to be set video mode, char mode. And I guess this actually allows me to yeah, wow, look at that. Shift delete for cut and paste. Oh, where's my Control C, Control V? Okay. So we've got set video mode. We're also going to want get video mode. So we're going to do, we'll say char. Get video mode. And, oh god, what's the function number for get video mode? Let's see. Give me 1 second. Get current video mode is F? Is that correct? No, I don't think that's right. Let me come back here. No, it is. Okay. Bam. All right. Awesome. So we are going to want to say ASM. We're going to move AH. We're going to say FFH int 10H. And what does that return in? AL? Yeah. So mov r AL. We'll call it ret. Makes it obvious. Char ret. And then return ret. So then in our main function, what we're going to do is we're going to say int. We're actually going to do, real quick, I'm going to go ahead and make a struct, which I'm going to call video. And one of the things I want to track in this is going to be a char, which is, we're going to call it OS mode, because now I'm programming this right now thinking, oh, Tandy 1000, but I don't know what the environment will be for the computer that's running this. So the very first thing we're going to want to do is go video.osMode equals get video mode. That way, we know. Let's get that on screen. So we want to know what video mode the OS was in before we switch to our selected graphics mode. And this is going to be important later on. Okay, and then set video mode. So then we say set video mode. We're going to say mode. And then what we are going to do is we are going to say return get video mode equals mode. So basically what we're doing is we're backing up the current video mode, And we're also going to go ahead and do a, what do I want? I want an unsigned char far star buffer. Now, in old school 16-bit coding, for using pointers that would extend beyond the current selected 64K segment, you would actually put two 16-bit values together, one to define the segment and one to define the offset within the segment. So to track the video buffer, because that is definitely going to be outside of our current code segment, we're going to use a far star buffer. And in fact, we should probably, while we're thinking about it, come to here, say code generation. Okay, so we're already set for huge. Huge basically means that the model tiny through huge, it's kind of how the instructions that or the C++ instructions that I'm giving it are going to be converted into assembly instructions and machine code based on how it wants to utilize pointers and addresses. Tiny makes the assumption that everything is going to fit into a single 64K segment. Small, I think, is your data segment and your code segment can be separate, but both of them are confined to 64K. It's like medium is then code is 64K, but data I think can have will track segment and offset. Large is both code and data, and then huge is just, oh fuck it, we're going to use any memory we can find. Basically, it's how complex the machine code for like dealing with any kind of address is going to be. So, just to be on the safe side, though, we are going to say unsigned char far star buffer, and we will go ahead and come down here, and we're going to switch our mode, case, video mode, Tandy. And in that case, we're going to set video.buffer equals mkfp, and I believe it's in A. Let's see. No. Okay. All right. Where is? Okay. 320 by 200. Here we go. Mode 9, and the address is not listed on this page. Thank you. I think it's B00. We'll find out. So let's go ahead and say 0xb123. mkfp is a macro. I probably need to... There we go. It's in DOS.h. Okay. Yeah, basically it's just a macro that allows you to give it two constants to assemble a long pointer. So you've got the segment and the offset paired. So let's... Oh, I'm so spoiled by... No, it was DOS.h. I'm so spoiled by modern text editors. I keep like pressing button combos, trying to jump ahead and what have you. And let's go ahead and say this as 0x09. So save all. Now before I test, I do need to get us out of that. So vquit is going to be set video mode, and this time we're going to say video.os mode. Because what we want to do is to finish execution, we're going to restore the OS's preferred. Is that too many? I have no idea how to spell preferred. Restore the OS's preferred video mode. Alright. So, we've got quit and init are both set. And so what we should see, if this works, is we will see the screen go black. And, I mean, we won't see it, I won't see it in emulation, but if we were sitting in front of an actual piece of hardware, you'd also hear the video display recalibrate to the new video signal. And we'll go ahead and say else, since we've still got that include, failed to set video mode. Always helps to have, no, I didn't want to say save as, always helps to have error messages. This is DOS, there's nothing catching us when we fall, so we got to do all the legwork ourselves. So, let's go ahead and compile, and hope that we don't get any errors. F6. Video mode Tandy. I forgot to include. No, I did include Video.h. Alright. Oh! Ew! Okay. Pound include Video.h. Save all. Compile. Make. And you might have noticed we've got the carets in front of some includes and is updated on disk reload. Yes? Yes. I have no idea what... Ah! Okay, this is an error I was expecting. Okay, so what I need to do is I need to go in and find TASM. So, Turbo Assembler and Turbo C++ were not originally packaged as one and the same. They were packaged as two completely separate tools. So, for Borland, for using Borland Turbo C++ today, you often have to go and find TASM. And we're going to copy this into... Okay, where is it? Dev, Gorgon. I'm going to go ahead and copy it. Now, this is going to require us to redo. Normally, you would have to, like, either unmount or what have you, but you can also, I believe it's Control F5. Ah, TASM.exe. There we go. So, let's jump back in, let it load everything up. F3, and then we're going to make everything. Undefined symbol. Let's go to... do I do it like this? There's a way for me to do this. I'm sorry, it's been a little while and I've forgotten. Yes, there we go. Okay. No, it really doesn't like... Alright, F3. Now, I know I've had code... In fact, well, that... Okay, bear with me. I'm going to have to check on some of my older code. So, we are going to look at our original. Where is it? Parser. There we go. And Morgan. Let's go down to video. No, I don't want to update my software. Oh, okay. Yeah, I can do that. We're going to go ahead and get rid of our assembler altogether. Actually, well, hold on. Where's my keyboard? Because I know I've done stuff with my keyboard. KB scan. Oh, does it have to be a... Ooh, okay. Okay, let's try it this way. Oh, no. Is it not able to... Let's try setting this to an unsigned. I don't know if that's going to fix it, but you know what? We're going to experience this together, and people who know better are going to be shouting at their screens. Sure. Error. Really does not like rat. It might have to be a static variable. I might not be able to reference. Well, I can. Oh, set video mode does it. So, hang on a second. So set video mode actually did convert my my local variable so that it was BP plus 6. So what is... Does it have to be a command line parameter? I don't know. This is actually kind of like curious. I'm puzzled, but no, I didn't want to reopen that. Close that. Okay, Video.c. So this it's perfectly happy with. But this it's not. Okay, so BP plus 6 was... Okay, so let's say BP minus 2. Is that going to be enough? Actually, I'm curious if I set it this way and say ret. File save. I mean, the alternative is just to set it to BP -2. Yeah, it doesn't like it. It's funny that it's not replacing ret with BP -2. Oh, here we go. Okay, you know what? We're going to hard code it. This is not something that you should do, but make exe. Now let's change that to a char. The difference between char and unsigned char is simply the sign bit. None of the video modes we're messing with will ever have the 8th bit, or I should say 7th bit, set, so it doesn't really matter. Okay, so compile. Did that successfully compile? Up to date? Awesome. Fingers crossed. Okay. Nice! Nice. Okay! Ha 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 ha! We've come out the other end. And just to verify, I am going to finish this with a printf. Thank you for playing. Okay, make exe. Run. Screen goes black. And if I do user screen, thank you for playing. Nice. So if I hit quit, save, yes. Oh, it's not setting it back. Ah, okay, we have a bug. vquit is not actually correctly running. So let's go down to vquit. We've got video.os mode. I'm wondering if that isn't breaking. Window user screen. Okay. So we're going to go ahead and add in a getch here to pause, and I'm going to say print os mode equals percent. What do I want? I want %d, and we're going to say video.os mode. This is going to mean we want to upgrade this to an int. File save. Okay. Compile. Run. OS mode is 0. Okay. Oh no, okay, that is correct. That is correct. So let's quit out, and we're going to type Gorgon. OS mode is 15 now. What's 15? 1.5, 80 by 25, 640 by 350, the Lava Chrome 2 EGA? What? Oh, sorry, 15 is no better. What is going on? Oh, wow. Okay. All right. We are going to... Whoa. I think I've broken something somewhere. All right, we are going to kill DOS for right now, and when we come back, we are going to replace our jank-ass assembly instructions with some actual libraries that we're supposed to use. All right, so see you guys in just a few minutes.